Okay, the next topic is factoring by grouping. So to factor by grouping means to group terms with common factors and then factor out the common factors and continue factoring until expression can no longer be factored. So if we look at this polynomial right here, x cubed minus x squared minus 25x plus 25, you can immediately see that 25x and 25 have something in common, so I'm going to put parentheses around, and then x cubed and x squared also have something in common, so I'm just going to separate them now and look at them and see if I can pull something out. I have x to the third and x to the second here, so I could pull out x to the second power here, and what I'm going to have left is, well, x squared times what is x to the third power? X squared times x. And then x squared times what equals x squared? Well, or actually negative x squared, it's just negative 1. So I'm going to have x squared times x minus 1 here. Now if I look at, so I write negative sign here first, then I look at 25x and 25. Well, what do they have in common? It's 25. So I pull 25 out. And what I have left inside here, I have x. And now, keep in mind, there's a sign in front, so negative sign, so negative 25 times x is negative 25x. And then negative 25 times what gives me positive 25? Well, negative 25 times negative 1 gives me positive 25. Now that we grouped and factored out each group of terms by itself, we notice that now both of groups share factor x minus 1. So now we can take that factor and factor it out of the whole thing. So we can pull x minus 1 separately, and then everything that's in blue would be x squared minus 25. Okay, so now we're finished with that. But let's see if we can factor anything else out. So looking at x squared minus 25, this is difference of squares. So if you remember, the difference of squares says that any time that you have something squared minus something else squared, you can write it as, so for example, a squared minus b squared is a plus b times a minus b. So if we apply this rule to our polynomial, x minus 1 stays intact, but we must recognize that x squared is x to the power of 2 and 25 is 5 to the power of 2. So really, this is our a squared and this is our b squared. So we recognize that x squared minus 25 is a squared minus b squared, and from that recognition we can use formula for difference of squares, a squared minus b squared, and we can rewrite what's in parentheses, x squared minus 25, as x plus 5 times x minus 5. And only now is our polynomial completely factored. Okay, you try this problem, pause the video, try it on your own, and then you can continue to see the solution. Okay, so one of the first things I noticed is that 9 and 18, they have common factor, which is 9. So I'm going to group them, and then I'm going to group x cubed and minus 2x squared. So if I look at the first one, I can pull out x squared here. I pull that out, and I will have x left for the first term, and then negative 2 for the second term. Well, for this guy I can keep that negative sign and pull out 9. So I'm pulling out negative 9. So I have x left, and then negative 9 times negative 2 is 18. Let's keep this same color. So right now we have x squared minus 9 times x minus 2. Again, x squared minus 9, that's a difference of cubes. So this is like a squared minus b squared, where our a equals x and our b equals 3. So we can rewrite this whole thing as x plus 3 times x minus 3 all times x minus 2. So in this example we can see immediately 8 and 4 and x squared and x cubed. So if we can pull out x squared in the first one. So x squared times 2x will give us 2x cubed, and then x squared times 1 is x squared. So that's that. If we pull out 8, or well, we cannot pull out 8, 4. We can pull out 4 out of the second one, and if we factor out 4, we have left 2x plus 1, and now we just need to group our factors, and we will have x squared plus 4 times 2x plus 1. And this is where we can leave this. Now notice one thing, this is not difference of squares. It would be possible to factor this out more, but right now we are only working with rational factors or with real factors. But I can show you what I would do with this one also if I wanted to factor it out completely, but that would include some imaginary numbers. I can say that x squared plus 4 is same like x squared minus negative 4. And then I can look at this as my a, where this x would be my a, and negative 4 would be my b, so this would be a squared minus b squared. Well, if this is my a squared, x squared is my a squared, then my a must be x. If my b squared is negative 4, I have to ask myself, well, what number to the power of 2 gives me negative 4? And that would be 2i, 2 imaginary. So basically I would have to rewrite this as x squared minus 2i squared, and only then could I factor that out as x plus 2i times x minus 2i. And let's check if that gives us our original problem. X times x is x squared. X times negative 2i would be negative 2ix plus 2ix, and then 2i times negative 2i would be negative 4i squared. So negative 2ix and positive 2ix would cancel. We'll be left with x squared minus 4 times negative 1, which would be x squared plus 4. So it is possible to factor this completely, but it would include some other roots. So really, it would be including all complex roots. The real factorization would be really x plus 2i times x minus 2i times 2x plus 1. But we are going to leave it in this form because right now we're dealing with real numbers only.